Our next pattern is the difference of squares binomial. So again, this is a pattern. It is something that you could factor without the pattern, though you see this one quite often. So this is one that I would definitely pay attention to because you'll see it all the time. In order to have a difference of squares binomial, our first and last terms must be perfect squares. So again, a binomial implies that there are just two terms. So we're saying both terms must be perfect squares and they have to be subtracted. If they're added, all bets are off. We can't factor that. So factoring the difference of two squares, we would take the square roots of each and then add them and subtract them. So let's take a look. Looking at my first example, I see that the first term is a perfect square because the square root is x, and my second term is a perfect square because the square root is 4, and they are being subtracted. So if I'm going to factor that, I'm going to factor it into the sum of the square roots and the difference of the square roots. So that's what the factoring of two squares the difference of two squares looks like. Now, if I did not remember this pattern, remember it would be like me looking for two values that multiplied to 16 that subtracted to 0, and those values would be positive 4 and negative 4, which is exactly what we came up with. Let's try another. On this one, again, I've reminded you that we should check for a GCF first, and we always should on every factorization question. But notice here that I can factor out a 9 first. So I'm going to factor out that 9, and that leaves me with x to the 4th minus 4z squared. And now I'm going to ask myself those questions. Can I take the square root of x to the 4th? Yes, because x squared times x squared is x to the 4th. Can I take the square root of 4z squared? Yes, the answer is 2z. Are they being subtracted? Yes. So my factorization is keep the 9 out front, and then x squared plus 2z, x squared minus 2z. Whoops. If I would have not taken out that 9 at the beginning, I would have factored this into 3x squared plus 6z and 3x squared minus 6z, and then I would have had to take a 3 out of both of these, and I would have had to take a 3 out of both of these, and I still could have ended up with the right answer, but it would have been sort of a mess. On my next one, I can take the square root of 4x squared. I get 2x. The square root of 25 is 5. However, if you'll notice, they are being added instead of subtracted. So this is prime. It's not factorable, however you want to say it. Go ahead and try these two, then press play to see how you did. On my first one, I can take the square root and get 2x, and take the square root and get 5y, and they are being subtracted. So that leaves me with 2x plus 5y and 2x minus 5y. For my second example, I would start by taking out a 3, and that leaves me with x squared minus 9. Notice I've written the 3 out front, don't just drop it. Now the square root of x squared is x, the square root of 9 is 3, so I can write x plus 3, x minus 3.